All right, this week we're going to talk about exploring. So we'll talk about task and content analysis as well as reframing a problem. So we are in this exploring area where we've got the problem framing, task and content analysis. Again, these blur across. Ideation can be explore, it can be create. Task and content analysis could be understand or explore. But this is where we are in the scaffolding we're using for our course. So like I said, the first video is task and content analysis, and I'm going to break that down into a couple sections I'll tell you about in a minute. And then the second video will be on problem framing. Okay, so task and content analysis. When an instructional designer is hired to support some type of learning, they often are not the content or subject matter expert on that topic. So they might be asked to help create a museum exhibit on biology or help a university professor create an online math course. The instructional designer themselves is not necessarily an expert in that area. And so they have to do some types of content analysis to understand what should be taught and figure out how and what order to teach things in. So they'll do a content analysis, usually with a subject matter expert, SMEs, and then other stakeholders. Like sometimes they'll include a learner or maybe another professor or a supervisor or whoever's paying them. And they'll get together to do a content analysis. And so I'm going to show you some methods for that in a minute. But first, it's important to understand the difference between an expert and a novice, because your subject matter expert is an expert. So what they say is going to be a little bit different than how novices will see it. So it's important to keep that in mind. I'm also going to talk about understanding like the structure of a content and then how we analyze it. Okay, so if we start with the expert and novice knowing, we're talking to the subject matter expert and they tell us about their topic. This is what you need to remember. The expert sees things in certain ways or patterns. They organize their content knowledge, they have all these experiences, they develop this way of acting and being in their subject area, and they don't even realize it. It just happens naturally. Whereas a novice, things are going to be different. They're not going to notice the same things. They don't have the same experiences, and they have to think a lot more carefully about each piece of something. So I think of this like when I had violin teachers. My best violin teachers were very good musicians, but they weren't virtuosos or child prodigies. Child prodigies a lot of time do not teach well because they don't realize how much background knowledge they already have. Whereas others a lot of time are more in tune with what the learner needs and can break things down better. So when we meet with a subject matter expert, we have to think about what's the background knowledge they're drawing on, because we're going to need to give that to our novices. So here's an example of how they tested this. There was just a whole bunch of physics questions. So here's some examples. And they asked physics students as well as professional physicists to group the problems by theme or concept. Okay, which problems go together? So the novices chose usually these two problems to go together because they look really similar, don't they? They look really similar. But the experts usually put these two together because these are closer conceptually. And I don't know the science behind this, but evidently the concept that this is showing is also represented here. So the expert looks at it differently. Here's another example in physics. They might have Newton's laws where they see things in like a concept map, versus novices might see things in forms of different types of equations. Okay. Another example of this is teachers' professional noticing. When teachers learn, they learn to notice certain things. Like when they say a teacher has eyes in the back of their head, they've learned what to look for in students. Not just about behavior, but also when students understand and when they don't and such. So I want you to watch this video, just maybe the first 4 or 5 minutes, and you'll see there is a student teacher type role, like an intern or student teacher, and then there's a supervising teacher. And I want you to watch when they see the situation differently and when the supporting or the supervising teacher decides to step in and help. So go ahead and watch that.
This morning when you were working your blue books, I was so...
Okay, now I just want to highlight just a little part of this. So we're just going to watch a little piece of it.
Has to be equal.
It means both sides have to be equal. So, bro.
What's another word for equal?
Okay, so they're talking about equal sign, and basically the students are just saying both signs have to be equal. Well, that's what an equal sign is, right? But the supporting teacher comes and says, "Hold on, what's another word for that?"
Same.
Same. Is there another word we could use?
Match.
Match. Another word we...
Focus.
Not focus.
Balance.
Balance. Destiny says balance. So both sides have to balance, don't they?
It's balance.
Okay, so this supervising teacher knows that we're not just trying to tell them what equals is. Like some students might be misinterpreting equals. And even the word same, like they might say 9 plus 3 or 4 plus 9 should be the same on both sides. So we're not looking for what's the same. We're looking for balance. And you see she's getting ready to use this manipulative she brought in to reinforce this concept. So you see how she is thinking ahead and planning to illustrate this concept with the students. So that's a way of a teacher who's more of a professional noticing something that's different than what a novice teacher would. Okay, so again, that's the difference between experts and novices. I just want to point out here, this use of this scale here, when we talk about pedagogical, technological content knowledge with TPAC, this is a technology, it's a tool that they're using for something. It's not digital, but it's a tool that they're going to be using to illustrate a certain concept. And the properties of the tool make it really work well, affords a good way to represent what this equals means and how it equals is balance. So I just wanted to point that out. That's the type of drawing upon content knowledge that we're looking for when we use technology. You'll see that throughout your different courses here. All right, on we go. So that's expert and novice knowing. So next we need to be able to break down and understand the structures of different content. So here's a framework that the book used, that we have facts, concepts, principles and rules, procedures, and interpersonal skills. So we might break down what students need to learn into these categories. So information-wise, facts, concepts, principles, and rules go together. So facts are basically memorized. Concepts are understanding relationships across facts. And then principles and rules are more like procedural knowledge or what to do with the facts and concepts. So for example, one popular way to do this in statistics is to learn the information or the facts about different statistical procedures. And then when it's time to get to this principles and rules, to use a decision tree that helps you decide which type of test to use. And so this is an instructional design that supports coming to understand those concepts and those principles and rules. There's a lot online you can see, but that comes from talking to experts and breaking down how they think about statistical problems. The other two are more task-oriented, and those are procedures and interpersonal skills. These are a lot more expert. They're much more they're much more complex. So a procedure is like a sequence of steps. Interpersonal is like your communication, your leadership. And so understanding what goes into a complex skill like this is very challenging. And so it requires a little bit of a different type of task or content analysis to understand. Okay, so we've talked about experts and novices. We talked about the content structure with facts, concepts, etc. And now we're going to talk about how you actually analyze content so that you can start designing for learning, designing the instruction. So one method is like a topic analysis. And this is kind of like a taxonomy, and this is from your book. I hope you read it, where you can ask a subject matter expert to describe a content area, and you can try to create some type of outline or taxonomy based on what the expert tells you about their understanding, because we're trying to group things in areas like an expert might see them. Okay, so that's a topic analysis. If you have a procedure, that's more complex, you might break it down like this. What does a learner do? What do they need to know to do it? And then how do they know when to do it? So I might know in baseball how to throw a ball, but I need to know when it's appropriate for me to throw that ball. What cues tell me when to do it? Okay. And then the other one, just briefly mentioned here, is a critical incident. So when you have something really complex, what you might do is talk to someone who is an expert and interview them. And you ask them, okay, tell me about a time when everything worked really well. Okay, tell me about an unsuccessful incident. And then you can compare those and try to pull out the components that differentiate a successful from an unsuccessful experience. And then you can use that information going forward to help learners learn how to have a successful experience. So again, it's about taking whatever the subject matter expert knows and trying to break it down in a way that you can then design some learning or some tools or materials for the students with that. Okay, so that is problem task analysis. And next we'll talk about problem framing.